This is video 1 for lesson 2 on Boyle's law for our gas unit, which is unit number 8. So we are going to be looking at a few of the gas laws. And these gas laws are relationships between those 4 variables of the gases that we defined: volume, temperature, pressure, and moles. So we can only compare 2 variables. So what the effect is of changing one variable when compared to another variable. So when 2 variables are studied, the other 2 variables are held constant. So if we want to look at the relationship between pressure and volume, that means that temperature and number of moles of gas cannot change. So we can see the direct effect of changing pressure on volume or changing volume's effect on pressure. So the first gas law that we are going to look at is called Boyle's law, named after Robert Boyle, who first described this in 1662, which is a long time ago. So we are looking at the relationship between volume and pressure, where temperature and moles are held constant. And what Robert Boyle did is he found that the product of the pressure and volume of the gas are constant. So if you multiply the pressure times the volume of a gas, it is equal to the new pressure times the volume. So if you multiply the two together, they are equal to one another. So that means as one thing goes up, the other one goes down. So if this is our original pressure and volume, and this is our new pressure and volume, he found that this is equal to a constant that we'll call K. But that is also equal to the new pressure. So this is what property in math? Well, this is the transitive property. And I double checked that with Mrs. Simpson, and it is correct. So if the product of the original gas is equal to a constant, and the product, if we change the variables, is equal to that same constant, then these two are equal to one another. And what this means is, as one of these goes up, the other one goes down. So these are proportional to one another. So as one thing goes up and one thing goes down, that means that they are inversely proportional. So as the volume of a gas increases, the pressure decreases, and vice versa. Now, if we look at this using the kinetic molecular theory, we can explain this. So temperature is constant. That means that the molecules are moving at a constant rate. Pressure is equal to the force of molecules hitting the container. So if we decrease the volume, that means that we decrease the surface area of the container. That means that we increase the number of collisions of the gas molecules on the container. Well, that increases the force, which then increases the pressure. So that means that a decrease in volume increases the pressure. We could use this to explain the opposite direction. If we increase the volume and increase the surface area, we decrease the number of collisions, which decreases the force and decreases the pressure. So by knowing this, we can explain this in words, but we can also explain it mathematically.